Imagine a future where wars are not fought with firepower alone, but with silent, precise strikes. Not missiles, not torpedoes, just stopping ships dead in the water. Instead of sinking them, a new weapon could destroy their propulsion systems, leaving them stranded and powerless. A warship that can't move loses its ability to engage the enemy. Its weapons are useless if they can't get within range. A cargo ship without propulsion is just a floating box, unable to deliver its goods. A stranded vessel is as good as neutralized. This concept is known as the propulsion disabler, PD, a theoretical weapon that could redefine naval warfare. It was proposed by Captain Bradford Dismukes and could take many forms: a small torpedo, an underwater drone, or a smart mine. Unlike conventional weapons that rely on destruction, PDs would focus on immobilization. Why sink a ship when you can just leave it stranded? A stationary target is vulnerable, unable to complete its mission, and forces enemy resources to be spent on rescue and recovery efforts. Officially, these weapons do not exist, at least not in publicly known arsenals. However, reports suggest that the CIA had a propulsion disabling system as early as 2018. There are also frequent hints in Chinese media about new underwater technologies that could operate in a similar way. Given the rapid advancement of drones, torpedoes, and smart mines, it is not a question of if propulsion disablers will emerge, but when. So how would a propulsion disabler actually work? Unlike traditional torpedoes that need massive warheads to sink a ship, PDs could be lightweight, small, and stealthy. A mini torpedo would be much harder to detect and far cheaper to produce, allowing them to be used in large numbers. Another approach could be smart underwater mines that sit silently on the ocean floor, waiting for a target. A third possibility is autonomous underwater drones, designed to mimic sea creatures, making them nearly impossible to spot. Some advanced drones can move between air and water, allowing them to be launched from submarines, fly above the surface, and then dive back underwater to engage a target. PDs wouldn't be dumb weapons either. They could be smart and selective, identifying ship types, distinguishing friend from foe, and targeting only the most important vessels. Armed with a database of ship signatures, a PD could recognize whether a target is a civilian tanker, a military destroyer, or a high-value capital ship. If necessary, PDs could swarm together, overwhelming countermeasures by attacking multiple propulsion systems at once. Disabling a ship is not just a tactical advantage, it's a strategic one. If you sink an enemy vessel, it's an act of war. It can trigger massive retaliation and escalate a conflict. But if you only disable it, the situation becomes far more complicated. A disabled ship cannot fight, cannot escape, and forces the enemy to respond. In a naval blockade scenario, propulsion disablers could halt enemy trade without firing a single missile, enforcing restrictions without creating an environmental disaster like an oil spill. Think about an oil tanker transporting crude through contested waters. Sinking it would be a catastrophe, sparking political outrage and an ecological disaster. But stopping it, that's different. The crew is safe, the ship remains intact, and the enemy is forced to either negotiate or send resources to recover it. The same applies to military warships. If an enemy destroyer suddenly loses propulsion, it becomes a sitting duck, vulnerable to further attacks, capture, or intelligence-gathering operations. There are multiple ways PDs could be deployed. They could be launched from submarines, airdropped by aircraft, or even dispersed by missiles. An underwater drone mothership could carry dozens of PDs and release them in contested waters. Torpedoes could deploy mini PDs in key choke points, cutting off naval access routes. Some PDs could even incorporate underwater glider technology, using buoyancy changes instead of propellers to travel thousands of miles while remaining undetectable. These gliders can stay operational for months at a time, waiting for the perfect moment to strike. Perhaps the most unexpected aspect of PDs is that the U.S. Navy's most criticized ships might be the only ones immune. The Littoral Combat Ship, LCS, often mocked for its lack of durability and firepower, has a unique advantage. It doesn't use traditional propellers. Instead, it relies on high-powered water jets, blasting 26,000 gallons per second. Disabling a warship with propellers is relatively simple. Cut the shaft, jam the rudder, or damage the blades. But stopping an LCS would require overcoming its water jet propulsion, making it much harder to neutralize. Ironically, this much-maligned ship might be one of the few naval vessels resistant to PD attacks. However, propulsion disablers could also create new challenges. If large numbers of ships are disabled, what happens next? A stranded vessel isn't just an inconvenience. It could drift into a storm, crash into a reef, or even collide with other ships, turning the ocean into a scrapyard of floating obstacles. In a large-scale conflict, entire shipping lanes could be blocked by immobilized vessels, creating unintended consequences that could be just as disruptive as traditional naval warfare. In a potential Taiwan conflict, propulsion disablers could be devastating. Thousands of smart mines, or PDs, could be strategically placed around the island, designed to activate only when a Chinese invasion force is detected. Instead of attacking indiscriminately, these weapons could prioritize high-value targets, disabling minesweepers, amphibious assault ships, and supply vessels. If rescue tugs arrive to tow the stranded ships, they too could be targeted, turning reinforcement efforts into a logistical nightmare. This would make a full-scale invasion incredibly difficult. China might still be able to blockade Taiwan with aircraft and missiles, but without functional warships, an amphibious landing would be nearly impossible. One of the biggest questions is whether propulsion disablers already exist. A Wired report from 2018 mentioned that the CIA had a propulsion disabling system. What exactly was it? No one knows. It could have been a high-power microwave weapon, like Boeing's Champ missile, which uses electromagnetic pulses to fry a ship's electronics. Or it could have been a cyber attack, remotely hacking into a ship's navigation and propulsion systems. Whatever it was, the fact that it was considered for disabling Venezuelan oil tankers suggests that some form of PD technology is already out there. Of course, like any new military technology, PDs would not be invincible. Just as drone minesweepers are being developed to counter traditional sea mines, similar systems could be designed to neutralize PDs before they reach their targets. Naval forces could invest in enhanced hull protection, counter-drone measures, or backup propulsion systems. The race between offense and defense would continue. But what makes PDs truly significant is that they wouldn't just be a tool for superpowers. Regional adversaries, groups like the Houthis or Iran, could use them to target Western ships in contested waters. A cheap, stealthy, and difficult-to-counter weapon that can immobilize a warship could be a game-changer in asymmetric warfare. PDs could turn minor naval conflicts into serious logistical and strategic nightmares. For decades, naval warfare has been dominated by missiles, torpedoes, and heavy artillery. But the real game-changer might not be a weapon that destroys ships. It might just be one that makes them stop.